In this last mini lecture for our planets, we're going to combine Uranus and Neptune into one video. Uranus is the 7th planet out from the sun after Saturn. Uranus was not discovered until 1781, and it was discovered by William Herschel. Uranus is small relative to Jupiter and Saturn. It is 4 times larger in diameter than the Earth and has 15 times the mass of the Earth. It is located at 19 astronomical units. Remember, 1 astronomical unit is the distance that the Earth is away from the sun, or at least the average distance. Uranus is difficult for us to study from the Earth, but even close-up images from a spacecraft called Voyager reveal that Uranus is actually rather featureless in its uppermost atmosphere. The atmosphere of Uranus is rich in hydrogen and methane. Methane gas and ice are responsible for the blue color of Uranus's atmosphere. So this is what's happening in Uranus's atmosphere. So you have light from the sun coming in from the sun. Remember, the sun emits light in all parts of the electromagnetic spectrum, and of course with our eyes we can only see the visible part of that spectrum. So light of all colors is coming, striking on the surface of Uranus. But what happens is that the red light is absorbed by the methane particles in Uranus's atmosphere. Okay, the red light is absorbed, but the blue light coming in from the sun is not absorbed by Uranus's atmosphere. That light scatters within the atmosphere and it reflects back out of the atmosphere. So that's why we see it as sort of this kind of pale blue color. Here we see the interior of Uranus. We've got the Earth for comparison. So the core that is of iron and rock is about the same size of Earth. And then above the core, we've got a layer of water, ammonia, and methane. And then above that, you have a layer of hydrogen gas. Now, Uranus has this rather unusual tilt. If you remember, I talked about early last week that Uranus's tilt is not straight up. It is on its side, okay? So Uranus is actually spinning on its side, not upright like all the other planets in our solar system, okay? So Uranus's spin axis is tipped so that its spin axis lies nearly within its orbital plane. The orbits of Uranus's moons are also similarly tilted. So Uranus's moons are also orbiting around it like that, not around it in the same direction as we think about the moons orbiting around our Earth or around Saturn or around Jupiter. Why is Uranus on its side? Well, one theory is that early in its formation, it was struck by another object and that tilted it on its side, laid it over on its side, splashed out some material from the planet that eventually became the moons of Uranus. Uranus also has a set of rings, although they are much fainter than those of Saturn. And those rings are also oriented around Uranus's equator, but since Uranus is tilted on its side, from our perspective, if Uranus is tilted on its side, then its rings are perpendicular to its path around the sun. Uranus has 5 large moons and several smaller ones that form a system around Uranus. These moons are probably composed of ice and rock, and many show heavy cratering. This is the moon of Uranus called Miranda, and it's unique in that it appears to have been torn apart and then reassembled somehow. So you can kind of see here, there are parts of its terrain that are sort of grooved, or they kind of look like they've been folded. But if you look at, if you've ever looked at some rocks, kind of like on cliffs of mountains, some of them appear to be kind of folded or bent on themselves. And that can only happen when the material is somewhat pliable and you're applying some force to them. Finally, we have Neptune, the furthest planet out from the sun within our solar system. Neptune is similar in size to Uranus. And the thing that I haven't mentioned yet at all is about the names of the planets. The planets are named for Roman gods. Just like how our constellations were named for Greek mythology, the planets are named for Roman mythology. So Neptune is the god of the sea. So named because, well, originally they thought that maybe Neptune was a water world because it was so blue. So that's why it's named for the god of the sea. Neptune is a deep blue world with cloud bands and vortex structures. It also has a great spot, kind of like Jupiter's great red spot, but we call it Neptune's great dark spot. Right here it is. And here are a couple other kind of dark spots too that are similar to that sort of hurricane-like feature of Jupiter's great red spot. Neptune was discovered from predictions made by two astronomers who calculated its orbit based on disturbances in Uranus's orbit. The interior of Neptune we think is similar to the interior of Uranus, mostly water surrounded by a thin atmosphere rich in hydrogen, and it probably has a rocky core in the middle too. So here we have the Earth for comparison. We've got our rocky inner core, we've got our layer of water, and then we have our molecular hydrogen gas. The blue of Neptune's atmosphere, just like Uranus, comes from methane in its atmosphere. And Neptune also has belts of clouds, just like Jupiter and also like Uranus too. Like Jupiter and Saturn, Neptune radiates more energy than it gains from the sun. But unlike Uranus, Neptune has cloud belts, just like Jupiter and Saturn. And similar to the way that Jupiter and Saturn get their belts of clouds, these come from deep interior convection, which causes material to rise to the surface, and that in combination with the rotation of the planet creates those belts of clouds that are alternating in different directions. And we'll end with a shot of Neptune's largest moon called Triton. And it's thought that actually Triton, this moon here, is a dwarf planet that was captured by Uranus from the Kuiper Belt. The Kuiper Belt is a belt of material at the edges of our solar system within which Pluto and other dwarf planets reside.